Okay, what would happen if we had y equals the absolute value of the cosine of x? What does absolute value measure? Like if I asked you what's the absolute value of 5, what would you tell me? It's 5. What's the absolute value of negative 5? 5. So what does absolute value measure? Distance from 0, regardless of which way you go, right? So the helper, I would just delete the absolute values here. Y equals cosine of x. And then the helper is just the standard sine wave. So you know the period is automatically 2 pi and the amplitude's 1. So the cosine wave. And then you could just plot that. Did I say sine wave before? It's the standard cosine wave. And so just to draw that picture once again, here we go. Something like that. And scale it the way we did before, 2 pi, pi. The 1/4 mark is pi halves. The 3/4 mark, this is the helper graph, so make a dashed line. 3 pi over 2 is the 3/4 mark. 1 is the amplitude, so it goes up to 1, down to negative 1. So that we essentially plotted these 5 points once again and connected the dots, although we did it backwards, didn't we? So remember, in y equals cosine of x represents all the outputs, all the height values on the graph, doesn't it? Y equals the cosine of x. Oh, y represents all the height values on the graph. So what happens if you take the absolute value of all the second coordinates, the height, stuff that gives you the height values? Are you going to is the graph going to be able to dip below the x-axis like it does here? No. In fact, the part that goes below the x-axis will just be reflected across the x-axis. They'll be the opposite height is what they were, because you take to take the absolute value of a negative number like negative 5, you take the opposite of it, don't you? The absolute value of negative 5 is the opposite of negative 5, which is 5. So all we have to do is the part of the graph with height values below the x-axis, those are negative y values, reflect it above the x-axis, and you're done. So in other words, the part that's above the x-axis, the height values don't change when you take the absolute value of them. They're positive already. So this part I'm indicating in green doesn't change. It's the same as the helper function. The part that will change, okay, I'll reflect this point. It was at a height of negative 1. You take the absolute value of negative 1, it goes up to positive 1. Likewise, for all the other points that have negative y coordinates, and you just get a hill instead of a valley. It changes to a hill. Well, I should do the same color. So something like that anyway. It's supposed to look like the same shape as the graph in red, as the part in red, but it's just opposite side of the x-axis. And then one thing I should point out is you do get sharp corners here at these x-intercepts. At pi over 2, it's a sharp corner. At 3 pi over 2, it's a sharp corner because it changes suddenly. And that's it. The graph in green is your final graph. Kind of looks like the path a ball would take if you bounced it.